We can also do manual processing of the thermogram if we think it is necessary to do some manual refinement. And for this, you can click here in the option All Injections and select Injection by Injection. So this is injection 1, and we can move forward to injection 2, 3, 4, and so on. So how can we do the manual processing of the raw thermogram? In this part of the project, in this graph on the left, these green bars are delimiting the region that is going to be taken into account to do the manual adjustment of the baseline and also to detect noise. We can move these bars to define the new or redefine this green region. And click here to refresh the selection. This threshold is going to define how many points or what is the limit you establish in order to detect noise. You can also change the threshold here. And on the right, in this graph, we are going to use the blue bar to define which is the region that is going to be integrated to obtain the isotherm. So it's the blue region. As you can see, we can move the blue bar to define the region that is going to be integrated. The yellow bar is going to define what we call the equilibration time, which is the time where we consider the injection is finished, and it's going to be necessary to design or to create the equilibration time curve to get the kinetic information. We can also move this yellow bar to do manual refinement, and we can click here to save the modifications. So we can do this for every peak in order to do the manual refinement of the raw data processing. The lower part of the KinITC project is showing two tables which describes the results of the thermodynamic analysis of the isotherm and the results of the kinetic analysis that is performed using the equilibration time curve together with the isotherm. The information you get here is obtained through the automatic analysis of both the isotherm and the thermogram, but of course you can also do modifications. You can do the manual, let's say, analysis of both graphs. So, for instance, in the thermodynamic, in the table of thermodynamic information, you have parameters that you can set as fitting parameters using this box fit, or you can keep them constant. For instance, I could consider that the binding constants Ka is going to be a constant parameter because I already know it. But typically we will keep Ka and delta H as fitting parameters, and then we can consider another parameters like Rm or the heat of dilution, Qdil, as constant parameters. Something analogous is happening with the table of kinetic information. From the kinetic analysis, we get basically K-on and K-off, the rate constants. So through the analysis, we obtain K-off from the analysis of the equilibration time curve, and K-on is obtained indirectly because we get the K-off and also the Ka from the thermodynamic analysis. So from these two parameters, K-off and Ka, ultimately we obtain K-on. Another fitting parameter that is obtained in the analysis of the equilibration time curve is the response time of the instrument. So this is a variable parameter that depends not only of the instrument you are using, which type of instrument, but also the experiment itself. So different titrations may give you different response times. Whenever you want to modify or do manual analysis of the experiment, you have to click here in Recalculate. And if you want to go back to the automatic analysis, just click in Auto. Another important thing that I have to mention is that by default in the automatic mode, you don't visualize the entire equilibration time curve, because this is typically the part that is useful. But you can also visualize the entire equilibration time, if you wish, by clicking in this button to move from auto on to auto off. So as you can see here, now we are visualizing the full equilibration time curve. And as you can see, the last points of the titration involve larger error bars, and this is because the last point, the peaks are of very low intensity, so they are not very much informative, and that's why we typically don't consider them in the analysis. So if we want to go back to the automatic mode to visualize mostly the useful part of the equilibration time curve, we just need to click again in Auto On. We can also delete points from the isotherm, clicking in the point and choosing this button, Trash. And if we click in this red button, we can undo this election of deleting points. We can do the same with the points of the equilibration time curve. As I mentioned at the beginning of this tutorial, we are uploading several files at a time, and we can visualize all the files here. So we can move from file to file to check or have a look to the results of the analysis of every file.